Hello students, I am Albunskuba. I am a faculty from the Department of Computer Science and Applications, Sri Vidya Mandir Arts and Science College Autonomous, Kateri, Uttangari. And in today's lecture, we are going to see about distributed operating systems. Right. So we'll move on to the topic. Initially, what is distributed operating system? So it is a collection of independent computers which are connected through network. Have a look at this picture. Here, each and every computers, each and every sites are of different sizes and which is having different functions and doing several different processes. All these networks are interconnected. So all these networks are interconnected. So this is a different network, this is a different network, this is also different, this is also different. So all these networks are interconnected with the help of a communication network for exchanging the data or sharing of the data. That is called as distributed operating system. Right. Now we'll get into the topic. Now we are going to see token based algorithm. So what is token based algorithm? So what is a token? You people might have heard about tokens. Say for example, if we are waiting in a hospital, they will be issuing some tokens for us. So whoever is having the token, they are allowed inside to see the doctor, right? So token is nothing but it is simply an entry point. If we are having the token, it shows we are allowed to get inside. So here also we are going to follow the same thing. In token based algorithm, a token is provided to each and every site. If a site wants to enter the critical section region without having the token, it is not allowed to enter into the critical section region. So in token based algorithm, what we are doing, each and every sites, each and every computers is sharing with the help of a token. So a unique token is provided to all other sites. Okay, right. If a site wants to enter into the critical section, it must possess its token, right? So token will be issued with the help of sequence number. So instead of providing timestamps. So in this lecture, we are going to see Suzuki Kasami broadcasting algorithm. So which was the algorithm from token based algorithm. So we'll see what it is. Right. In Suzuki Kasami broadcasting algorithm, have a look at here. If a site wants to enter into the critical section region, it must possess its token. So without having the token, a particular site can't able to enter into the critical section region, right? Say for example, if I don't have the token now, but I want to enter into the critical section region. So what I should do? First I should ask who is having the token. After receiving the token only, I can able to enter into the critical section. So I will be broadcasting a message. What is that message? Have a look at here, people. Here I am broadcasting request message to all other sites. I am broadcasting a request message to all other sites. So all the sites will be receiving this request message, and the site which is possessing the token will be also receiving the request message. If it is not in the critical section region, it will be given back the token to the requested site. If it is in the critical section region, after the completion of critical section region, it will be providing the token back to the requested site. So this is what we are doing in Suzuki Kasami broadcasting algorithm, right? Okay, have a look at here. We'll see with an example. So Suzuki Kasami broadcasting algorithm. Here we are having all the completely connected network which is full of processes. Okay, so one network will be having the token and the remaining networks won't have the token. So the token which the site is holding is the owner of that token, right? It is its responsibility to complete the critical section region. After finishing off that region, it will be providing the token to the requested site. So this is what we are going to do now. Okay, have a look at this diagram. In this diagram, we are having 5 different sites. Okay, the red color marks. So these are all 5 different sites, and we have a yellow dot over there, right? That is called as token. So one particular site is having the token and the remaining sites are not having the token. Okay, we'll see with this example. Right. So this is what the algorithm. So if a site wants to enter into the critical section region, that particular site must possess token. If it doesn't have the token, it must request, it must broadcast a token message to all other sites, so that the site which is holding the token will be receiving the request. After that, it will be providing back to the requested site. So token, in the sense, it is a queue of requesting sites. It will be holding a queue. Whoever is requested, that will be holded in the particular queue, and it is maintained in an array. Okay, right. So this is what the design issue. So design issue, we are requesting as well as we are maintaining a queue. So based on the outstanding token request, we are issuing the tokens. Let me explain you with this example. Have a look at here, guys. Here we are having 5 different sites. Initially no one is requested, so all the sites are marked as 0. Okay, totally how many number of sites we are having? Rn1, Rn2, Rn3, Rn4 and Rn5. Totally 5 different sites we are having. Okay, so for mentioning the 5 different sites, we are marking it as 0. So have a look at here. So after this, what we are doing, have a look at here. Which site is holding the token? Rn3, that is site 3 is holding the token with it. The remaining site is not having the token. Totally we have 5 sites. Out of 5 sites, this third site Rn3 is holding the token, that is marked in yellow color. Okay, right. Now have a look at this diagram. That is site 5, Rn1. So Rn1, first site, wants the token to enter into the critical section region. So I am marking it as 1. Have a look at here. So this one. So it needs a token to enter into the critical section region. So it is broadcasting a message to all other sites, so that all the sites will be marked as 1. See here, this is marked as 1, this is marked as 1, this is marked as 1, this is marked as 1. So all other sites are marked as 1. Okay, so that it come to know that first site wants to enter the critical section region, so it is broadcasting a request message to all other sites for getting the token. Clear? Okay, right. Now have a look at here. So it is broadcasting a message here. After receiving this message, this particular site 3, Rn3, is providing the token to the Rn1. That is, after completion of the critical section region, the token is no longer needed. After completion of the critical section region, the token has been given back. So it is given back to Rn1. Now look at this diagram. In this diagram, the token has been passed from Rn3 to Rn1. So it has given back the token to Rn1. Right? Now Rn1 is holding the token. It is having the authority, it is having the rights to enter into the critical section region. Right. Now it is working in the critical section region. Now again in the queue, 2 more requests had come. 2 more requests, 2 and 3. So 2 more requests had come. So out of that request, it has to enter into the critical section region. Right. Now have a look at here. Out of these 2 requests, again it has to broadcast a message. From the Rn1, it has to broadcast the message to all other sites. So what is happening? Have a look at here. So it is broadcasting a message, so that it will become 1 1 1 1 1 1 1 1 1 1. So see this clearly. So 2 more requests had come. So Rn1 is broadcasting a message, request message to all other sites, so that the queue will be forming as 1 1 in the second and third value. Okay, second and third value, it is broadcasting the request message to all other sites. Okay, right. Now what is happening? After receiving this request, this token has been given to the second node. Okay, so after receiving this request, this particular token has been moved on to Rn2. Okay, Rn2. So it will now, Rn2 is having the rights to enter into the critical section region. So after finishing its request, see here in the queue we are having 3. Okay, after finishing of that, it is giving to the Rn3. have a look at here, RN3. Now RN3, that means third site is holding the token. It is having the rights to enter into the critical section region. Right? Now one more request has come. That is Q of 5. Okay, Q is equal to 5. So fifth site, RN5, is requesting the token to all other sites. So now RN3 is holding the request, so that the next point will be 1, so that the token will be given back to RN5. So like this way, with the help of token, all the sites will get its work to be done. Okay, so this is called as token based algorithm, Suzuki Kasami broadcasting algorithm. It was an algorithm which is fully dependent on token based algorithm. So thank you.